everyone, my name is Sethi. I hope you all are staying healthy. Today we will see introduction of mathematical economics with MCQ, especially for UGC Net in economics. First of all, we will see introduction about this important topic like input-output model, linear programming, optimization problem and their application. We will also see differentiation, matrix, sets, functions, sequences and series and their application in economics. So let's start it. Input-output model. Input-output model is given by Wesley Leontief, who received Nobel Prize in Economics for his work in 1973. As we know, all sectors of economy are depend on each other. For example, agricultural sector provide raw material to manufacturing sector, services sector provide crucial service to manufacturing sector like transportation, insurance. So all sector of economy are depend on each other. An input-output model is quantitative tool that uses linear equation and matrix to represent and analyze complex interdependency among different sector of economy. That means this model shows how output of one industry uses as an input for another industry. For example, output of steel industry uses as an input for car manufacturing industry. Input-output table which shows how different sector of economy are depend on each other. Agriculture, industry, final demand, total revenue. Agriculture, industry, labor demand directly depend on final demand. That's why these two also related with each other. Row wise you can see total revenue, and this is total revenue which is earned by agriculture sector by selling its input as a final demand, by selling its input to industrial sector by using its own input. So this is total revenue which is generated by agriculture sector. Similar, this is total revenue which is generated by industrial sector, and this is total income which is earned by labor. So row wise you can see total revenue and column wise you can see total cost. Agriculture sector pay to labor 150 rupees, pay to industrial sector 100 rupees, pay to itself equal to 50 rupees, and this is total cost which is bear by agriculture sector. Similar, this is total cost bear by industrial sector, and this is total cost which is bear by labor. So here you can see in the agriculture sector can use their own input. Similar, industrial sector can use their own input, but labor cannot consume themselves. That's why here we have a 0, and total revenue of each sector is equal to total cost. Total revenue and total cost equal to each other in case of agriculture sector. Similar, total revenue and total cost are equal to each other in case of industrial sector, and total revenue and total cost are equal to each other in case of labor. I have already made a video on input-output model. I will also make especially for UGC Net with some important MCQ. Currently, just revise this model. This is fundamental equation. After rearranging this equation will look like this. Solution is founding by using inverse, and this inverse will called Leontief inverse, and shows input requirement from all sector needed to produce 1 unit of final demand in specific sector. X shows total output of all industry in economy. D shows final demand, means external demand, demand by consumer, government and export. Linear programming. As we know, in economics we face so many problems. For example, how to maximize our profit, how to minimize our cost. Linear programming provide best, or you can say that optimum solution for all these problems by using a linear equation. Linear equation means where variable have power 1. In this equation you can see x variable have power 1, so it will be called linear equation. But here x variable have power 2, it will be called non-linear equation. In linear programming we always use a linear equation. Linear programming have two fundamental parts. objective function and constraint. Objective function means what is our main goal, what is our main objective, what we want to achieve. We want to maximize our profit or minimize our cost. A constraint means our problems, our limitation, resources limitation, like we have a limited amount of money, limited amount of manpower, machineries. So constraints are our problems, and within these constraints we have to achieve our objective, and linear programming help how within constraint we can achieve our objective. For example, company want to maximize its profit by producing two goods A and B, and maximize Z shows company want to maximize its profit by producing x1 unit of A goods and x2 unit of B goods. 10 is per unit profit from A goods and 15 is per unit profit from B goods. So this is our objective function. We want to maximize our profit. Constraints are our limitation, our problems. In order to produce x1 unit, we need 3 resources. In order to produce x2 unit, we need 4 resources, but resources are not available more than 30. So this is our constraint, this is our problem. Within these constraints, we have to achieve our objective. Constraint mainly have two forms, equality and inequality. In case of equality, you will see this kind of sign, and in case of inequality, you will see this kind of sign. So this equation shows inequality constraint. Optimization problem. Core part of optimization problem are utility maximization, profit maximization, cost minimization, and revenue maximization. Objective function in case of utility maximization represent by this. We want to maximize the utility of consumer. U represent utility, x1, x2 represent quantity of goods. Constraint, our limitation. Budget is limitation of consumer. P represent price of goods. I represent income of consumer, which work as a constraint, which work as a limitation. Profit maximization, we want to maximize our profit. Profit is difference between total revenue and total cost. TR total revenue, TC total cost. Q represent quantity of goods. Constraint, this is our objective function, but what is our limitation, what is our constraint? Constraints are our resources, technology. Cost minimization, L represent labor, K represent capital, W is cost of labor, we are paying wages to labor, R is cost of capital, which we want to minimize. Our constraint is they must produce specific amount of output. In order to solve optimization problem, we can use calculus based method, Lagrange multiplier, linear programming, dynamic programming, and simulation method. Now we will see one optimization problem. Pi is the profit, Q is our output. We have to find out level of output which give us a maximum profit. In order to find this, first of all, we will do differentiation of pi with respect to q. So we will do differentiation of pi with respect to q. Differentiation of 500 will 0, and differentiation of 200q is 200, and this 2 will multiply with the 20, and this power will reduce by 1. It will become equal to 40q. So this is our derivative, and we will find out value of q, and value of q is equal to 5. So 5 is our level of output. Now we have to see this level of output is giving us maximum profit or not. If second derivative is negative, then this output is definitely giving us a maximum profit. So now we will do, means now we will find out a second derivative. This was our first derivative. From this we will find out second derivative. Differentiation of 200 is 0, and differentiation of 40q is 40. So here you can see our second derivative is minus 40. So if our second derivative is in minus, then this output level is definitely giving us maximum profit. Sets, function, sequence, and series. Sets are well-defined collection of distinct objects, and we use sets in economics to describe consumer preferences, utility, combination of production possibilities, and market equilibrium. There are so many types of function in economics. Explicit function where dependent variable is directly function of independent variable. Y is dependent variable, X is independent variable. Dependent variable is directly function of independent independent variable. But in case of implicit function, dependent and independent variable are mixed together. X is independent variable, y is dependent variable, which are mixed together in case of implicit function. Linear function where variable have highest power 1. In case of quadratic function, variable have highest power 2. In case of exponential function, constant is base, variable is in power. 2 is constant which is in base, and x is power which is, x is variable which is in power. Similar, we have demand function which shows inverse relationship between price and demand. Demand is dependent variable, price is independent variable. As price increase, demand fall. Similar, we have supply function which shows positive relationship between supply and price. As price increase, supply also increase. This is consumption function which shows a relationship between income and consumption. As income increase, consumption also increase. Sequence and series. Arrangement of number with some specific rule will be called sequence. Here you can see 2, 4, 6, 8, 10. Each number have 2 gap. That means some rule are apply here. You can easily predict the next number will be 12. Sum of sequence will be called series. When you add all these sequence, it will be called series. Application of sequence and series in economics. Geometric sequence used to show GDP growth rate, inflation rate. We can use sequence to track annual production, stock prices. We can use geometric series to calculate future value of investment. Plus we can use series to calculate fixed payment for loans. Derivatives. Derivatives help to measure rate of change. In economics, we mainly use concept of derivatives for marginal analysis, optimization problem and calculating elasticity. Now we will see one example how to calculate elasticity by using a derivative. Formula dq over dp into p over q. dq over dp means we will do differentiate with respect to p. P means price. Here p is initial price, q is initial quantity. Given initial price is 10 and given demand function is this one. From this given demand function, we will find out initial demand. In order to find out initial demand, first of all, we will put 10 in place of P. When we put 10 in place of P, it will become equal to 160. 160 will be called initial demand. Initial price 10, initial demand 160. Now we differentiate with respect to P. And when we differentiate with respect to P, differentiation of constant variable is 0 and differentiation of 4P is equal to 4. So in place of dq over dp, we will put minus 4 and in place of P, we will put 10. In place of Q, we will put 160. When we solve, it will become equal to 0.25. Differential equation. Differential equation include dependent variable, independent variable and derivative of dependent variable with respect to independent variable. Independent variable, dependent variable, derivative of dependent variable with respect to independent variable. A differential equation have two types, ordinary and partial. Ordinary differential equation having derivatives of dependent variable with respect to only one independent variable. Partial differential equation have two or more independent variable and their partial derivatives. And in economics, we use differential equation in case of economic growth model like Harrod-Domar, Solow. We use differential equation to calculate GDP, inflation rate, to analyze saving and consumption. Plus, we also use these differential equation to analyze patterns of trade cycles. Given the total revenue function, find out marginal revenue. This is a given total revenue function. Marginal revenue is a derivative of a total revenue with respect to quantity, or you can say that with respect to x. When we do derivative with respect to x, our answer will come B. Derivative of 100x is 100 and derivative of x square is 2x. So B is our right answer, or you can say B is our marginal revenue. In input-output model, matrix used to show interdependency between different sector of economy is called, as we already discussed, input-output model is given by Vesely-Leontief. That's why our right answer is B, Leontief inverse matrix. The objective function in linear programming problem. There are two fundamental parts of linear programming problem, objective function and constraint. Objective function shows the goal of problem, either maximization or minimization. For example, we want to maximize our profit or minimize our cost. So our right option is B. Function to be optimized, maximized or minimized will shows objective function linear programming problem. A single point that satisfies all constraint in optimization problem is called. Constraints are our limitation, our lack. For example, we have limited resources, limited manpower, and a single point that satisfies all constraint in optimization problem will be called feasible reason. So our right option is C. Given the consumption function, what does this slope B represent? Slope of consumption function represent marginal propensity to consume. As we know, marginal propensity to consume shows how much consumption change in response to change in income. This much change in income lead to this much change in consumption. This slope shows marginal propensity to consume. So our right option is C, marginal propensity to consume. Now introduction about all economics has completed. That's why now I will make a video on each topic in detail and with some MCQ. So this is all about today's video. I think you got it, and thank you so much for watching this video. Bye, take care.